All right, here we go. Welcome to week 7. We're going to start off week 7 by reviewing some stuff that we did way back in intermediate algebra in the 9th grade, and it's solving proportions. And then later in the week, we're going to make things a little bit more difficult, and we're going to deal with some translating of words into equations and solving. So this week is generally going to be a little bit lighter as far as the volume of work goes, but the second part is going to be more challenging because we have to take words and turn them into math equations, which is always a little bit challenging. But for the first part here, what we're going to do is just solve proportions. And when we're solving proportions, especially something like this first example where it's relatively simple with just one variable and then 3 numbers in the 2 fractions, what we can do with these that a lot of people don't realize is we can actually rearrange some things to make these a little bit easier to work with. And what I mean when I say that is, so for example, normally when we're solving this proportion, what we would do is we would cross multiply, right? So I'm just going to put an x in here that says cross multiply, right? And when we cross multiply, we're going to multiply the x times the 5 to get 5x. Okay, so normally that's how we would start. And then we would multiply the 45 times the 7. And right there, you can kind of see 45 times 7. That's something that most people probably can't do in their head. Some people probably can. But we end up with a really big number, and it's easy to make mistakes with big numbers. And so what we can do, when I said we can rearrange things, what we can do is we could rewrite this proportion, and we could just take the x and the 5, and they could switch places. So we could say 45 over 5 is equal to x over 7. Okay, so this is kind of how my mind works when I see problems like this. I see a relationship between the 45 and the 5 because 45 can be divided by 5. And then I say, hey, wait a minute, if there's a relationship, if I just switch those 2 places, it doesn't change the proportion at all. But what it does is it makes it easier for me to solve this proportion because 45 divided by 5 is the same as 9 over 1 if I leave it as a fraction, which is then equal to x over 7. And now when I cross multiply here, I end up with 1x, or just x, is equal to 9 times 7, or 63. Okay, so I didn't have to think a whole lot about that because I know what 9 times 7 is, and it ends up allowing me to get the answer pretty quickly. Now, we could do the same thing that we did to this one, to the original problem. We could cross multiply, but in this case, we're going to end up with 5x is equal to 45 times 7. Well, we need a calculator to do 45 times 7. Let me see. I think I did it over here. Yeah, so here we go. 45 times 7 is 315, so we could go ahead and put 315 in there. So you can see right away that now this one isn't quite as simple as the other method that we used because we've got bigger numbers, and bigger numbers are harder to deal with. And so what we could do then is divide by 5. And even 315 divided by 5, we probably are sitting there scratching our head a little bit like, I'm not sure what that is. So what we could do is do 315 divided by 5. And it says 63. Well, look at that. We got the same answer. Okay, so we know that x is equal to 63. All right, so there's 2 ways that we could solve this proportion. And the first way, where we moved the x and the 5, is totally fine. The only thing you can't do is you can't switch things from numerator to denominator in the same fraction. So you wouldn't want to flip the 5 over 7 over, right? You wouldn't want to flip the 45 and the x over. But if you did both, if you flipped both of them over, that'd be perfectly fine. You never want to do something numerator to denominator in one fraction, but if you're going from one fraction to the other, that's totally fine. One other way to think about this one is if we think about the original problem, and when we have relatively simple ones like this, what we can do is we can just kind of look at it and say, hey, what's the relationship between 45 and 5, right? Well, I need to take 5 times 9 and it equals 45, right? That means I do the same thing in the denominator. 7 times 9 equals x, so x is equal to 7 times 9, or 63. Okay, so sometimes what happens is we have this process called cross-multiplying that ends up getting in the way of us understanding really what's happening. And so sometimes it's easier just to look at them and say, what's the relationship between the two numerators? Well, in this case, it was times 9. So that's all I have to do to the denominator to figure out what x is. Okay, so 3 different ways we could solve a relatively simple proportion. Now, that isn't going to always work with the proportions that we're going to deal with. And so, for example, in this one, there isn't really a relationship between the 3 and the 5, and then in the denominator, or in the numerators, we got binomials, and so there's no real relationship there. So what we have to do here is we don't really have a whole lot of choice. We need to cross multiply. So we're going to go ahead and cross multiply. But when we do, we have to be super careful. And what we have to be careful about is these binomials. I've tried to say it as much as possible over this entire unit that binomials are linked together. Okay, so the x and the 5 are linked together by the minus sign. The x and the 2 are linked together by the plus sign. And if they're linked together, if we multiply it by a number of some sort, we have to distribute whatever that number is to both things that are in the binomial. Okay, so in this case, when we cross multiply, we're going to end up with 5 times x minus 5 is equal to 3 times x plus 2. Okay, so we just have to distribute twice on each side. So we're going to distribute the 5 and we're going to distribute the 3. So we have 5x minus 25 is equal to 3x plus 6. And then this is just a simple equation where we have variables on both sides. I always like to, if possible, I say if possible because sometimes it's easier to do it the other way around, but if it's possible, I always like to try to move the smallest variable first because that then avoids negative numbers. So I'm going to move the 3, so I'm going to subtract 3x. So we have 2x minus 25 is equal to 6, and then I'm going to add 25 to both sides. So I end up with 2x equals 31. And this one doesn't end up being super nice and neat because 31 is an odd number. We can't divide it by 2 without getting a decimal, but we can still do it. And when we divide an odd number, we're always going to end up with something that has 0.5 in it. And so in this case, we end up with 15.5. Okay, so we are able to solve this proportion that has binomials in it because we added parentheses. Now, if you don't add the parentheses, you end up with something that is completely different, and it's not going to work. All right, one more. Okay, this time, the only difference with this one is really we have one binomial. We have a binomial that has a 3 as a coefficient on the x, which changes things a little bit. We could look at this and say, hey, is there a relationship here? Yeah, there's a relationship between the 6 and the 5. They both have 3 as a common factor. So if you want to mess around with that, you could look at dividing both of those by 3 to make the numbers a little bit smaller if you wanted to. The other thing that you could consider that we did to the first one is when you cross multiply here, you could consider switching those two, the places of those two, because then you have the 27 and the 6 in the same fraction, and you could do a little simplifying before you cross multiply. But if you're not into that, that's okay. Just go ahead and cross multiply. But remember, put that in parentheses first. And when I'm doing these, if the variable is only in one spot, I'm going to choose to do that one first so it's on the left side of the equation. Okay, so I'm going to do 6 times 3x minus 2 equals 11 times 27. Whoops, I don't want that. There we go. So in this case, the numbers end up getting kind of big on the right-hand side. 11 times 27, so that's, 297. So I'm going to go ahead and say this is equal to 297. And then I'm going to go ahead and distribute on the left-hand side. So we have 18x minus 12 equals 297. And then what I'm going to do is add 12 to both sides. And so we have 18x equals 309. And we're kind of at a point where, I don't know, if 18 goes into 309 or not. And this is where you could grab a calculator right away and do this, but there's other ways to kind of think about this too. One thing you could do here is 18 and 309 are both divisible by 3. So I'm going to divide both of them by 3 just to simplify things a little bit. And so I have 103. And then 103 is not a number that is divisible by much of anything. So if we think about it, 6 isn't going to go into 103. 2 isn't because it's an odd number. 3 isn't because it's just not going to. So I divide by 6, and I have x is equal to 103 over 6. And the only thing I really want to do at this point is just kind of check. If I go to my calculator and I do 103 divided by 6, it's 17.166. So it's a decimal that just continues on, right? And when we have decimals that continue on, what we do is we leave them as fractions. So no decimals, right? Only decimals that are nice and neat, like the last one. But if you have something that continues on, we don't want decimals, we want fractions. And the whole reason is because with a decimal like that, we have to round it. And when we round it, it changes the value a little bit, and it ends up being not quite the number that we want. Okay, so a little bit random on some of the things that we did today, but just different ways to kind of think about these and look at these and ways that you can manipulate them. And so it'd be great if you would try on some of these down here to move some stuff around, do some simplifying before you actually solve to see if it actually does make it easier or not.